Some good news for everyone that this day 3 of multi-step inequalities, if you look at all the different examples of the problems, I give you 4 different problems on your notes and your slides. To be honest, all of these you've probably solved before, but they were equations. Do you know how to get rid of distributive property or get rid of the parentheses with the distributive property? Do you know how to do that? Okay. Do you know how to simplify both sides of an equation? So could you simplify both sides of the inequality? That's one thing to keep in mind. I want to go back to, let's go back to one thing we constantly talked about when we solved equations was that each side, in order to start doing, like using those properties of equality, you know, like adding 2 to both sides or dividing by something on both sides or multiplying something, before you could do any of those properties of equality, you had to make sure both sides of your equation was as complicated as what? What's the most complicated a side could be? You guys remember how we discussed this over and over, okay? Justin, do you remember what could you have on each side?
One constant, one variable.
One constant, one variable. Now you could have less than that, right? But you couldn't have any more than that. And if you can remember that from equations, today will be no different. Most of these will be, I mean, I think third hour, you're like, this is the same thing. I go, exactly. It's the same idea. The process is the same as equations, hasn't changed at all. The only thing difference is instead of an equal sign, we have inequality symbols. And we have to graph our solution. Okay? Maybe the other thing that we have to make sure that we flip. Yeah. We have to flip our signs if we multiply or divide by a negative number. So, if this is, make sure that if you have questions, ask as we go on. So, let's think about what we have in this first inequality. What does your instinct tell you? What would you do? I mean, if you just got this on a quiz or a test, would you know even how to attempt it? Lainey, what does your mind tell you to do?
Combine the variables.
You guys agree we have 2 variable terms? And what did we just say? We only can have what? One on the side. So that obviously violates the code, right? So we have to make sure that we simplify. So let's do that. And if we do that, you should notice something. So if we put the 2 n terms together, what is our new n term, Alexa?
Negative 3n.
Negative 3n is greater than, it's a little slow, but we're going to see if it's a little bit faster than earlier. So right here, do we have to simplify the other side? Is that one? You can have a 3 on there, right? You can have 1 constant. All right, so from here, hopefully all of you are thinking 1 step. What's the 1 step that's going to get us n by itself? What do we have to get rid of, Ben? All right, so he says that to get rid of multiplication, he's going to divide. You guys agree with him? I agree. So we're going to divide by negative 3, based on the fact that a number divided by itself is equal to 1, right? We want 1 value of n. We don't want negative n. We don't want the opposite of n. That'd be the whole opposite of what we want. So we have, what do we have on the left-hand side?
N.
3 divided by negative 3 is? Negative 1. All right. Now, when we bring our inequality symbol down, is there anything that you're thinking of here? Penelope, what do you got?
We have to flip the sign.
She said you have to flip the sign based on what? Why do you have to flip the sign?
Because you're dividing by a negative.
All right, you're dividing by this negative 3 right here. And that negative also tells you that that less than sign needs to be flipped. All right, so now we're going to take and flip the sign. And obviously, negative 3 divided by itself is just an n. Everyone okay with that? All right, let's graph this. And we'll move on after the check. There we go. It's moving a little bit faster today. This morning, it was not moving at all. So we have negative 1 here. Is it going to be open or closed on that negative 1?
Open.
Open. And we're going to put a negative 2 here and a 0. Which way are we going to head? Which one of those would be true? Which one, Trey?
We're going to the left.
We are going to go to the left because remember I told you guys could rewrite this, couldn't you? But remember the little point is facing the end, so when you rewrite it, you have to make sure that little point is also pointing to the n. So really n is less than -1, not the other way around. All right, so any questions on that? Now let's check. Who wants to give us a good number to check with? What value of x should we use, Maya? -2. So we're going to plug in 3 is less than -5 times our n plus 2 times our n. And we're going to put in, come on, don't quit on me now. There we go. So we're going to put -2 here and a -2 there. And when we simplify the right-hand side, we have, what's -5 times -2? 10. And a 2 times -2 is? -4. And when we take 10 and -4 and put it together, 6. And that has to be greater than 3. Do you guys agree that either 3 is less than 6 or 6 is greater than 3? We true? We're good? All right. So one thing you're going to notice is we're going to get more complicated as we go here, guys. But hopefully, all combining terms on the side, you know how to combine like terms, right? And that's basically what we've added here on these. Are we going to close off the T here? Or last, oh, there it goes. Okay. So as we look at the next problem, if you notice, we have grouping symbols. So what is the only way that we can get the x outside of the grouping symbols?
That scared me.
Who's that?
Was it phone?
I don't know. Oh, it's probably one of the tests on the radio, like Andrew
Or
said.
it's like when iPhone.
Oh, is that what it is?
That's what it
sounded
That's
like.
what it sounded
Oh,
like.
it's one
Oh, it maybe my iPhone was doing that? Huh?
It's when they like Amber alerts and stuff on your
Oh, that was probably, yeah, because those alerts are on my phone. Okay, here we go. So can someone share this? How are we going to get x outside of the grouping symbol? What's the only way we can do? What's the only thing we could do? What do we have to use? 2 people know? 3? Come on. Hannah?
You multiply the stuff inside the parentheses with the number that's right outside the parentheses.
Now, can we combine -3 and -6 first?
No.
No. Think about that. That's addition, isn't it? What is the distributive property? What operation are you really using with the distributive property? Ben? Think about gens. What comes first? Addition or multiply? Multiplication. That's why you distribute first. Then you can combine like terms if necessary. So make sure, guys, when we distribute here, okay, you need to make sure that you distribute it with the -6. So is -3 even involved at this point?
No.
No. So we're just going to bring that down. And now when we distribute a -6 to a positive 4x, what do we get? -24x's. And then we have -6 times a positive 6 is a -36. And we bring everything else down. So again, what would be the next step that we'd have to use? What would we have to do? Can we start moving things from each side? Can we use the property of equality yet? No, why? Why are we not able to do that? Lainey?
Because you need to combine like terms.
You have to combine like terms. So make sure that every time you see an inequality, that should be something that you, obviously just like an equation, you have to make sure that you only have one variable, but we have 2 constants here. How many constants can we have on a side? 1. So we have to bring those constants together and combine them, and what do you get? Huh? -39. So we have, so now we have 1 constant, 1 variable, and that should be an okay side, and then we only have a constant on the other side. So from here, this is a 2-step inequality, is it not? From here? Would you guys like to solve it? And then I'll meet up with you at the end. Why don't you guys go ahead? I'll give you a second to continue with the problem, and then we'll solve it and check it together. my work look okay? When I combined, put a positive 39 on both sides. Now to get rid of multiplication, I'm going to use division. Hopefully you guys use division as well. And when I bring my inequality symbol down, I'm going to flip it. You agree? Okay. So instead of greater than, x is going to be less than positive 3. And then I'm going to graph it. So I have an open dot on 3 as soon as it shows up here. All right, so I have 3 here. I'm going to have an open dot on 3. And then I'm going to, okay. Which way? We're going to go to the left. And I would absolutely check with 0. Based on the fact that 0 is over here somewhere, right? So, there we go. So now I'm going to plug 0 in. So I have negative 6. I have 4 times a 0 plus 6 has to be greater than negative 111. I wish I could see my work. There it is. All right, so now we're going to simplify this. Inside, I have a negative 3 minus 6. And what's inside my parentheses here? What's 0 plus 6? 6. And that has to be greater than negative 111. And when you multiply negative 6 and 6, what do you get? Negative 36. And that with another negative 3 also has to be greater than 111. And I think it's negative 39. Is that greater than negative 111?
Yes.
Yes, it is. So we are good. It checks. We're good to go. So we can move on to the next one. Any confusion there? All right, we're on the third slide, Noah. If you want to join us, we're on this one now. Thank you. Would someone like to suggest something that we could do? Olivia, what would you do?
Combine x.
We can combine x's on both sides, right? You guys agree that we have more than one variable term on each side. So once you simplify both sides, obviously that's what you're doing. This is what you have to make sure you understand is that before you can start putting things on both sides or getting rid of terms, you have to combine like terms on each side and simplify it down. All right. So if you can remember that from equations, really, could I just replace an inequality symbol and put an equal sign? You could have done this, couldn't you? Back when we did equations. Sure, you could have done this. So now, we got how many x terms on negative 8x and positive 2x? How many x's do we have? Negative 6x's minus 16 is less than. And when we put negative 5x and positive 7x would be positive 2x. So now, unlike any of the other problems, you should notice that now we have variable terms on both sides. Anybody remember anything I told you with equations? No, do you remember anything that?
Try to make x positive.
You
on
could.
both sides.
Do you have to though?
No.
No, you don't have to make the x term. Whatever one you get rid of. Okay. What else, Ben?
Put a variable on one side and one side.
All right. We want to make sure the variable terms end up on one side and the constants on the other. Does it matter which term you get rid of?
No. Yes.
In this problem, it does. But when do you guys notice that on one side you're missing a constant? You don't have a variable constant on each side. You guys agree with that? Okay. So which one of these boxes would you get rid of? Which one would you suggest, Jocelyn?
Negative 6x.
Because if you put negative 6x on the other side, don't you have the constant left over there? But if you got rid of 2x on the right-hand side, what would you have on the right-hand side if you got rid of 2x? Nothing. Now you got everything on the left-hand side. Then you're going to have to move one of the terms back. Do you see how you just added a step for yourself? All right, so if you have one constant, just say, okay, that's the constant side. All right, let's move the variable term on the other side. So how do we get rid of a negative 16 or negative 6x? Huh? Add 6x or positive 6x. All right, so now we're going to bring Now, have we flipped the sign yet?
No.
Okay, remember, adding or subtracting or putting positive and negative numbers down does not flip the sign. Okay, so now we have negative 16 is less than 8x, and obviously what we can do on both sides to get x by itself, Trey?
Divide by negative 8.
Nah, divide by what?
8. Just 8.
Yeah, just 8. So does that flip the sign?
No.
No. So now we have x is greater than negative 2. Now again, can you rewrite the inequality where x is on the left-hand side? Absolutely. But this time we have couldn't see where my line ended on that one. We got negative 2, negative 3, negative 1. I'm going to put an open dot on negative 2, which my line.
On negative 2. On negative 2.
I did put it on there, it just changed. All right, so let's pretend we have an open dot there, and then we're going to go right or left? To the right, because x is going to be greater than that. Okay? So again, now obviously we can check this. All right? So really, if you notice, when I plug in all these x values as 0, and I have negative 5x is 0, I have 7 and 0. Okay, so if you notice, 8 times 0 and 2 times 0, what's this all equal?
0.
0 and negative 16 is what? Negative 16. It has to be less than 5 times 0 and 7 times 0, which is also what? 0. So you guys agree that 0 is greater than negative 16?
Yes.
Sure it is. That checks. All right, let's do one more. Now, if you notice, we have variables on both sides. You guys agree that we have n's on both sides of our inequalities. We also have parentheses, which we have to use what property? So this one puts everything together. Okay? I'm going to be honest with you. If you can solve this one right here, I'm going to let you do it by yourself. Because if you can solve this, this is the most complicated an equation on your test would be, or inequality, excuse me. This is probably the most complicated we'll get. You might have distributive on both sides. Okay? But distributive will be present. Combining like terms would happen. You might have to flip. Scary. Okay? So, if you can solve this by yourself, as long as you know that, hey, I can put another distributive property in there somewhere, this is probably the most complicated it's going to get. And if you notice, we haven't done word problems. So word problems won't be on your test this Thursday. But you will also have, you know, from one-step inequalities to two-step inequalities, distributive property, the fraction ones. And it's all going to be similar to your quiz last Friday. Do you guys like to set up like that? Like the quiz on last Friday? Would you rather me put boxes around each problem, or put more space between the problems, or
No, that was
it was okay? A little bit more space maybe would help some of us? Okay. And I'm even thinking if you want to use loose leaf paper, you could. You know, I mean, if you like the lines on a loose leaf, you know, I don't care. All right, I'm going to solve this, and you guys want to make sure I'm doing it right? Match yours with mine? Is that cool? All right, so I got, you guys agree the left-hand side's cool? Everything's good? It's simplified. As soon as the rest shows up, there she is. Oh, there it is. And you guys realize that I picked this up before it showed up and it turned green? I didn't write it for green. You notice that? Look at the end.
Yeah.
The one end, because I picked this up when it turned to green. How cool
You should
is
do that
that?
again.
Let's see, we got nothing changes yet, so we got, what, negative 41n and positive 42 on the right-hand side? Because this side's not going to change. Check that out. Am I okay so far? All right. So now if I look like this, now Noah, does it matter which one I pick to get rid of this time? Because you have constant with the variable term on each side. You guys agree with that? It's like, it's tied up at this moment. Each side has the same number of variable terms as constants. Okay, so we're tied up. Which one would you get rid of? It doesn't matter. You can get rid of the negative 5n or the negative 41n. But which one would you think I would get rid of? Hannah?
The negative 41n because then you have a positive n on the left side.
Remember I just told you guys about I hate negative. I guess I don't hate. I just don't like working with them because how many times have I forgotten those negative signs? I see you guys do this all the time. And if you can prevent one negative to be forgotten, let's try to keep it positive if we can. I don't know if that helps any of you, but I'm just saying for me, being a student, not too long ago, by the way, you know, it's the point of if we can prevent something from happening, that's better. Okay, being proactive is good. All right, so here we go. I'm going to get rid of this negative 41 with a positive 41n. There she is. And we got, what, 36n plus 6 is greater than or equal to 42.
Why is it taking so long?
It's, I don't know, it's just something that my screen just is taking a little bit longer today. I don't know. Has a mind of its own, Noah. It's a computer technology.
Robots.
So we're going to subtract 6 on both sides. I'm going to get 36n is greater than or equal to 36. I'm going to divide by positive 36. Does that flip the sign?
No.
No, it does not. So n is greater than or equal to 1. You okay with that? I really wish I had room above my problem because this one with 1, I'd love to go left to right above the problem that's given to me, and I could check it. Because really, negative 5 times, or 1, wouldn't that be negative 5? So we have negative 5 here, plus a 6, that would be what? 1 is greater than or equal to, and I put 1 here, what do you get? 5, right? Minus 6 is? Negative 1 and a negative 7 make a positive 7. And then I'm going to put 6 and that 1 together. What do you get? Negative 6. So then here, what's 1 is greater than or equal to what? 1? Is that true?
Yes.
Sure is. And I used 1. I probably shouldn't have used 1, huh?
Use 2.
I could have used 0. 0 would have even been better. But you can't use 0. Why would you use 0? It's greater than. I forgot to graph it.
Yeah.
Oh, yeah.
Yeah, because my board really gives me the opportunity to check.
Thoroughly.
We have a closed dot on 1. You pretend? Closed dot on 1. Arrow's going in the right direction. So you could have used 2.
I used 2.
I probably would have used 2.
I used
All right, what I want to guys, since you guys are the same as third hour, is that cool if I just give you the 4 problems I gave them?
Yeah.
All right, and then tomorrow we'll work on some more in class. Wednesday we'll put all the different types together, mix them up. Okay? Is that cool? And then Thursday's your quiz. So really, this is kind of the last day of instruction for me. My last teaching experience for 2014. It's right here.
Wait, make your best effort for 2014. Make your best effort for 2014.
Well, I'm.
How do you feel?